I think I'm mic'd up. Can you hear me? Nope. Yes? Yeah. OK. And there we go. Thank you so much, Nir. Hi, everyone. I'm Gilad. I lead the data science team at Betaworks. We're a startup studio here in New York, actually just a few blocks away. And oh, there's not a monitor here. So what we do is we build companies. So we're a startup studio, unlike incubators. Thank you. Companies come to Betaworks or start at Betaworks typically and stay for a long time. And currently, we have about 13 companies within the space. You may recognize some of the companies who launched out of Betaworks. So after a few years, companies grow and literally don't fit the space. So Bitly and Chartbeat came out of Betaworks. Dig is currently incubated at Betaworks. Giphy sort of left Betaworks, I guess, last year. Right? And we have a number of other companies. And what we also do is seed investment. But the majority of what happens at Betaworks is building companies. And that's what I want to talk about, specifically some of the stuff the data team has done working with early stage products on really helping them scale fast and adding data features. Right, so what do? We're effectively a shared resource. Right? So you have this startup studio. You have all these different companies at different stages of growth. And what we do is we help them with whatever issue they may have. So that may be effectively like a little consulting session saying, well, if I were to build this is what I would do. This is what I would recommend. And it goes all the way to sort of actually building out the thing. So let's say Dig needs a recommendation engine. It would come in, really like build whatever infrastructure needs to be built, and then maintain it for a while until we can hand it over. Right, so most of our stuff is, it's product focused. So we're building the products. We're focusing on things that we can reuse also. So a scoring or ranking system for Dig can be potentially reused for Instapaper in many ways, because they're both sort of media content. And we do continuous R&D. So we try to collaborate with lots of players. We have a number of interesting projects going on with different university labs. We bring in interns and fellows throughout. So I want to go through two very quick examples just to give you a sense for the range. And I'll dive into one a little deeper. So Pancho, how many of you have heard of Pancho? Some of you. So it's a cute little weather app that launched from Betaworks. It's kind of like your mother telling you about the weather. Right? So no charts, no numbers, no math. Very easy, like here's what you need today. Take a scarf. Don't forget your hat. Right? And there's usually a GIF and some funny message. So it started out literally as someone waking up in the morning, kind of checking weather.com, and then sending out a funny message to other people in New York. It became more and more personalized. So, oh, given your commute, here's what you should know about the weather today. Here's what you should do with regards to your commute and their allergies. So we're starting to sort of include all these personalized signals. But there's always a human in the loop. There's always somebody making the joke. Right? So it started out this one person getting up in the morning, sending a message to all of the folks in New York. But that doesn't really scale. Right? If you want to start covering other parts of the country, you can't have a human per zip code or per group of zip code, because there's no way you can actually build a company there. So we developed a method based on the editor heuristics. We call it dynamic heuristic subspace clustering, where what we're doing effectively is saying to the editors, well, what are the things that you care about? And they tell us, well, wind speed, we don't care as much about wind speed unless it's really high. Then we really want to tell our users to take a scarf. Right? But temperature is very important at these ranges. Right? And precipitation probability is super, super important when it reaches a certain threshold. Right? So given all these heuristics from editors, then we can say, well, we'll find groups and regions of zip codes that we can group together. And then instead of sending one message per close region per single zip code, then we send a message to a region. And we're doing this in real time. So whenever the editors want to send a message, they plug into the system and they see, well, what zip codes are associated in terms of similarity of weather patterns, but also given heuristics of editors. Right? So it's a really powerful way to scale the product using data science. Right? And now the company is, I think they have about 20 people, all these editors. They cover all the state. So without sort of doing using these sort of clustering mechanisms, there's no way they could have scaled. I'll quickly talk about Dig, more saying that there's, on the face of it, how many of you use Dig or consume content from Dig? OK, so a bunch of you. They're effectively the homepage of the internet, trying to appeal to people like you. Sort of what are the big things you should read today? You'll always go to dig.com and see like pretty high quality content, almost no repetition. And it's kind of the big stories of the day with some sort of geeky hat on. There's always also some great kickers. So those are the sentences right under the images. But Dig is powered by editors. They effectively choose what content to place on Dig. But they have all these tools in the back end that we built that effectively crawl the social web. We get a lot of signal from social. We get a lot of signal about what people are reading, too, and sort of try to identify outliers. So articles that are performing significantly better than the norm for that domain. And I'll get a little bit into that later. So again, we have this sort of region where data enhances the work of humans at Betaworks, where effectively what our system does is empower these editors to be able to sort of get a better grasp for what's going on the internet. What are the big stories? What's performing significantly better? And then at the end of the day, they choose what goes on Dig. So I want to talk to you a little bit about a new product that we recently launched called Scale Model. And I was so excited to see all the talk about graphs and network analysis earlier today. Here's another bit of it. So I hope you're ready. And I don't think it's repetitive. So at the core of Scale Model is this attempt to understand influence and localize authority. So it's this notion that marketers really want to plug into business people. But really, when you look at social networks and you're trying to understand sort of why things spread, why people share certain things or don't share other things, you're really trying to understand influence. So what makes someone take an action within the social network? And when we look at networks like Twitter, we're thinking about the spread of information, right? So if someone has the ability to disproportionately affect the spread of information, we call them, we say they have high influence, right? If in other cases where we're looking at data, we may look at purchasing patterns, or we may look at television viewing behavior, right? But we're really always talking about this disproportionate effect. And especially in social networks, we care about specific context. So in a given context, there's a wanted action, like spread a piece of information, right? So with that in mind, let's start sort of observing and looking at these graphs. So this is, many of you have worked with graphs, and sort of the basis of it, we're taking objects, and we're trying to understand the relationship between objects. We map that out. And effectively, we start sort of building this great map of objects and their relationship. What we really care about is a way to understand the shape of this sort of massive network that we've built. Because by having an understanding of the shape, we can get a much better sense for attributes like who's most central, who's an authority, where are the groups that are important, right? So especially when this data is based off of human interactions or people's relationship, it can be, we can glean a lot of insight from being able to sort of understand the shape, right? So we talk about different measures of centrality, right? Who is most central in a network, different measures that we look at. We think about clustering coefficients. So where do we find cliques? So these are groups that are highly connected or all connected together. And then we think about modularity, or we try to look for groups that, again, display high connectivity. So using Scale Model, what we do is we input a series of words. We say, well, we want to understand the sort of conversation around the upcoming US elections. So we may take a few seed inputs, like the different candidates and some sort of words that they tend to use in social media. This example is based off of Twitter. And then we expand the network. We find many sort of users like them. And there are many approaches to do that. And I do not have time to get into that at this point. But then we map out the network. So who are these people, and how are they connected to each other? We rank, so in this case, nodes are users. We rank nodes by their centrality. So how many other users are they connected to? And then we color the graph by modularity. Where are there groups or regions in the graph which display higher levels of connectivity compared to the rest, to the whole graph? Right? And we come out with something like this, where there are very clear regions of the graph which have some shared interests. Right? In the case of Twitter, people tend to follow each other or either because they're friends with each other or because they're interested in that person. So that interest graph is really, really interesting. Interest graph is really interesting. I should pick another word. But when you map it out, actually, you almost always see these sort of densely connected clusters emerge. So here we get conservatives in red, liberals in blue, and then different campaigns as they're forming. What we did, though, is we said, well, we wanna sort of get a better sense for these communities and really untangle this sort of homophily that's at play in this networks. And we build an interface that's actually real time. I didn't put a GIF in there, but all this stuff kind of moves as data comes in. And what you're seeing here is sort of the dashboard, the scale model dashboard for the US elections community. And the stuff you get on the left, we call it user power. So these are users who are central at that time, at that moment. And they're scored by their centrality measures, right? So we take different degree centralities and how central they are within their specific clusters, right? We think that's a really important measure, and it definitely helps us assess sort of who is generally popular and who is sort of popular within that context of that group, right? Well, other things that come up are attributes of what they're sharing. So what are the top hashtags, languages used, top websites and pages. And again, we kind of get a sense for the content that they're sharing. We can also see, this is the big board view, so we kind of get a sense for what media they're sharing. And this is really incredible to watch when sort of a big event happens. Let's say someone famous dies, or some terrible thing happens. The whole board changes, and you really see sort of a community being swept away by this event that takes place. So we can do this for any community as long as it's there on the social network. Right? So we have an animal lovers community, which we absolutely love. It's great for anything related to animals. I'll show you a screenshot of that in a bit. But we can go humor, we can find moms, we can find YouTubers. And really the interesting thing about sort of using social signals for this is a lot of these attributes don't have to be articulated by the user, whereas the network displays such power in identifying these groups by interest that even though I don't say I'm a YouTuber, because I'm connected to so many YouTubers, we can strongly infer that I'm most likely a YouTuber, or I'm a big YouTuber fan. So we can do this for all these different topics, and we actually started doing is trying out different targeting techniques. Twitter has an ad targeting platform, and by saying, well, if you really want to reach Stephen King fans, there's no good way to do that. But actually using these techniques played out really well. So something we've also been playing with is this notion of sort of identifying top trends from these communities, because we don't expect users to, or users of the system to sit on that dashboard all day. As pretty as it is, you have probably other things to do. So it's important for us to be able to distill what are the critical things they should know, and what's important to sort of notify users in real time versus sort of give a summary view. So here you see three very different types of sort of trends that we identified from the data. Some are cyclical, right? You see these weekly patterns. Some are daily. Some are bi-weekly. Some are just sort of trending once, right? So you get this incredible, this is love wins in the middle. You get this incredible velocity at the beginning and then sort of dying down also pretty fast. And what we do is we use a technique that's fairly well known. We use time series decomposition to really untangle the different aspects of the trend. So if, for example, our trend is what you see on top, this sort of cyclical time series information that's sort of trending upwards. It's actually comprised of multiple elements. There's the trend component, which takes the median of every cycle and sort of maps out how that looks like, and then the seasonal component. And what we do is we subtract that from the actual data, and we get the residuals. And then using some pretty basic statistics, we can identify outliers in the data. So what are the points that are significantly different from the rest within the residual? So using this technique, we can actually find something like World Elephant Day. That was an event that we'd never seen before, but identify that it's important at the right point in time and send that message to our user. So this is a screenshot of our animal lovers community, by the way. One thing I didn't say is we're not using any textual features here at all. So that's the amazing thing. Like, we've never built one classifier to identify like animals or words that represent animals. We're only using social features. We're only using the social network and people's likelihood to connect to people like them with shared interests. Right? So these things that come up, the people who shared them, that image of a lion, means that a lot of central people in this community shared that picture of a lion. They can share anything. They can share lots of things, but obviously they're more likely to share images of animals. So what we did is, again, as a process, as a way to train our event detection system, we actually started funneling it into Slack. And we have our little gossip chimp bot that sends us important things when they're triggered. And this helps us sort of set the right thresholds. And we can upvote or downvote the content. So Slack has actually been a really useful tool in this case, because otherwise we'd have to sit on a website or get a ton of email or get the messages somehow. But on Slack, they sort of go to this channel. Everyone or people who are helping us build the service upvote or downvote it, and then we can sort of tighten up our own mechanism. And just to give you a sense for where we're at, so we recently launched this tool. We don't really know what we're going to do with it yet. We're at the point where we think it's really interesting. We've used it. We've sort of played around with a few different partners. And we're in the process of trying to figure out which direction we'll go. There are a few routes that we could go. But in the process, we've collaborated on a few different topics that are really interesting, in my opinion. So one was with a researcher in California who was looking at the anti-vaxxer sort of bill that was proposed last month. And using a scale model, she was tracking for a few months the techniques of the anti-vaxxers on the network and how the network itself changed along with their techniques. And a really interesting Wired article came out of that using our data and our graphs. And luckily, the bill didn't pass, so yay. Another thing is actually from earlier this week. So how many of you have seen the Shout Your Abortion hashtag or heard of this? Right, so this is sort of a movement that came online really rapidly. And there was a New York Times write-up yesterday about this specific hashtag and who started it and sort of what they were trying to achieve. But again, show support for Planned Parenthood funding was sort of the simple way to describe it. But what we did is we looked at, again, the communities sort of interacting and engaging with this sort of trend. And you could very easily map it to a few sort of dominant regions. So you very quickly get the feminist groups. And you have, again, look at the different colors. You have two regions identified by difference in modularity. And this is a place where I'm no domain expert there, but when we bring on a domain expert, they clearly see and they clearly understand why this sort of seemingly single cluster of feminists actually is split into two. And then on the other side, there are conservatives, sort of the conservative cluster. And what you don't see here is the Gamergate cluster. But then what we can do is say, well, how does this look over time? And this is an amazing GIF made by Brian Clifton on the team. And you could see it starts. The feminist kind of hops around and then is seeded by the Gamergate folks. Media comes in, and then everything blows up. So again, what's really interesting here, and I think earlier talks today, we're mentioning diffusion and different aspects of diffusion. we have a system now that sort of can track these communities, but also we have an incredible amount of data that we're getting through GNIP, actually. So it is possible to do Twitter work. It's just not that cheap. But we can sort of track not only the communities, what they talk about, but also how they change over time. Thank you. So it says we're out of time. I don't know if we're actually out of time or
On time, so.
Perfect.
Any questions?
Oh.
We'll just take one again.
I answered everything.
Awesome. Thanks so much.
Thanks.